All right, find the area in the standard normal distribution in the left tail more extreme than z equals negative 2.45. So this right here is kind of like me talking about the p-value. So the first question I had here says, just what's the z-score? Okay, the z-score is 0.05. Is that an unusual z-score? The answer is no, it's not. This one already gives me the z-score and says, hey, can you tell me the probability? All right, so let's think about this. I'm going to draw a picture to think about it. I think this is going to make us go to stat key. So here's my best normal distribution. In the middle is our population information, or we could say z equals 0, right? We're at the middle. So that's like being at mu or maybe at p for proportion. We, from the empirical rule, know that if we go, say, 2 standard deviations to the right, or left, sorry, and 2 standard deviations to the left, we would find about 95% of what's going on. Here, my z-score is further over. So here's a third one. So this guy right here lives right in the middle. Z equals negative 2.45. So I can estimate that. If I know 95% lives from negative 2 to 2, that leaves 2.5% in the tail. So I'm guessing that this area over here is probably less than 2% is my rough guess. Okay. And that's like finding a p-value. So another way to state this question is, what's the probability a z-score is less than negative 2.45? Let me just double check. Find the area and the standard normal distribution in a left tail, which is less than, more extreme, more left, because I'm out here in a tail, that's extreme to the left. So that, again, confirms that less than. So 2 things there. To answer this, I got to go to stat key or a spreadsheet. I'm going to go to stat key. So from the stat key homepage, we want to head over to theoretical normal. Quick link in there. Chat in the video. Normal. Calculator. So here I am, and at first it's set to 0 and 1, which means I got z-scores on the bottom. So a mean of 0 and a standard deviation of 1 is a distribution for z-scores. Then I want to say left tail and plug in my z-score at the bottom. So negative 2.45, and stat key says, oh yeah, that's way less than 2%. It's 0.0071. That's definitely less than 2%. My estimate wasn't good, but it wasn't horrible, maybe. So stat key tells me that this area right here is actually 0.0071. Did I get that right? Yep, less than 1%, 0.7%. Oops. Button. There we go. So I got it. So that probability is approximately 0.0071. Now, stat key only gives us about 4 decimal places of accuracy. So if we ever need more, we would have to go to a spreadsheet. So a quick look at this on a spreadsheet. Which we'll use more probably next week, but I'm not going to use it too much this week. Stat key is good enough for most of the stuff we have. And let's see, do we have a normal one here? No, let's just make a new one. Sheet. And Google Sheets, Excel works the same way. Normal calculations. So here I was given a z-score. Z equals, I'll put it in this cell, negative 2.45. And based on that, I want to calculate the probability that, in this case, z is less than whatever number I have. I'm just going to put that there for now. Pick a new number. So it's a good thing that this is a left tail, because that's what a spreadsheet does really well. So equals, I start typing normal and it gives me tons of normal options. I want the normal.dist. I'll write this down in the notes. The normal.dist wants an x value, which could be a z-score, mean, standard deviation, and then we always want to put true. We could put false, but don't. It's meaningless for 99.99999% of humans. So here, my x value is above. This is a z-score, so the mean of z-scores is 0, is the middle z-score, and the spread of z-scores is 1. And then I just do true, close parentheses, enter, and I get the same number of stat key with a ton more decimals. So I'm going to share this out. Restrict it. Copy. Spreadsheet version. Chat and in the video. If you want to get in there and give it a shot. So you could make a copy of this if you want to use it, but don't make a copy yet because I'm going to do a couple more calculations here. And again, so again, the formula that I used here was norm.dist, and it wants what's your x or z, they just call it x, what's the mean, what's the relevant STD, that depends, and then always type true. It doesn't have to be capitalized. And what this calculates for us is a left tail. If you want a right tail, then we got to pull another trick on it. I'll show that in a moment. So stat key is the easiest way to do this, in my opinion. Alternatively, sometimes we use a spreadsheet. And the left tail probability on a spreadsheet is always norm.dist x mean STD, whatever that is, and then true.